Hello everyone, welcome back to my channel. In the last lecture, we saw about different type of dimensions in array, accessing the elements, slicing, copying and viewing the array and much more. Today we are going to continue learning NumPy. Alright, so the very first thing of today is to see about the shape of an array. If we give my ARR as a name of the array, then NumPy, okay, first we should import a NumPy. So import NumPy as NP. My ARR dot is equals to NP dot array, then parenthesis and square bracket 1, 2, 3, and 4, 5, 6. If we print this and also my ARR dot shape and see, then you can see first the array is printed as it is a 2D array and then its shape is printed. Now if we say AR2 equals to np dot array and then nt min is equal to 3 and then we'll print array and its shape. So you can see this was our initial array and the second array is this, which was empty, and its dimension is this. Alright, now let's move. If we need to reshape from one dimensional to two dimensional, like if we want to convert the 1D array with 12 elements into a 2D array. So the outermost dimension will have 4 arrays, each with 3 elements. So 12 elements means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now new ARR equals to ARR dot reshape 4, 3. And then we will print new ARR. So you can see we had given 4, 3. So 4 rows and 3 columns like this vertically. Now converting 1D array with 12 elements into a 3D array. The outermost dimension will have 2 arrays that contain 3 arrays, each with 2 elements. So for that, we can have the same array copied here. We can comment and write 1D to 3D. A new RR is equal to ARR dot reshape and then 2, 3, 2. Let's print this. And you can see this 3D array is formed. So it is like I have already said, the outermost dimension will have two arrays that contain three arrays, each with two elements. You can see it here. This is one, this is two, and three inside, and then two elements. Now, if we move to unknown dimension, so we are allowed to have one unknown dimension, meaning that we do not have to specify an exact number for one of the dimension. We can just write -1 as the value and NumPy will calculate it for ourselves. So if we convert 1D array, let us take with 8 elements, to 3D array with 2 cross 2 elements. So 8 elements, new array is equal to arr dot reshape, then 2 comma 2, and we can just write -1. It is for the unknown dimension. Print new arr, and then if we run this, you can see 2 cross 2 matrices are formed. Now the next thing is to flattening the arrays. Flattening the arrays. Flattening arrays means converting a multi-dimensional array into a 1D array. So we can use reshape -1 to do this. Like if we want to convert an array into a 1D array, then arr is equal to np dot array parenthesis than 1 comma 2 comma 3 and 4 comma 5 comma 6 new rr is equal to arr dot reshape -1 print new arr. So you can see this is printed in 1D array. Now next thing is iterating the array. Iterating the array. So iteration means going through elements one by one. So if you want to iterate on the elements of a 1D array, then first let's create a 1D array. There should be only one square bracket and this is a 1D array. Then for loop is used here for x in our array, that is arr. We need to print x. So you can see 1, then 2, and then 3 all are printed. If we iterate on a ND array, it will go through n-1 dimensions one by one. Let's try iterating on each scalar element of the 2D array. We can just copy paste the 2D array from here and then for loop is used for x in arr, for y in x. It's a 2D array and so therefore for loop is used twice. We need to print y. So you can see 1, comma 2, comma 3, comma 5, comma 6, all 6 are printed in different lines. If you use the for loop only once, the 2D array will be converted into 1D array. Now Next thing is to iterating arrays using an the iter and the iter. Mm. So if you want to iterate to the following 3D array, which I'm going to write 1, comma 2, comma 3, comma 4, comma 5, comma 6, 7, comma 8, and then parenthesis. Mm, there should be one more square bracket here, I think. Alright, so if I write for x in np dot nd iter arr and then print this x. So you can see all the elements are printed in different lines and we do not have to use for loop again and again. Instead, we use another thing which is nd iter. So the next thing is to enumerate on 1D array elements. So for this, we can take a 1D array. Then we'll have to write for idx, comma x in np dot nd enumerate array and then print idx, comma x. So you can see first indexes is printed and then the elements are printed. IDX is index here, so both of the things are printed. So now the next thing is to join arrays. Let us take array 1, could have copied it from here. And then we can take a second array 2 as 4, 5, 6, and then arr is equal to np dot concatenate. Concatenate simply means to join arr1, comma arr2, and then print arr. So you can see both the arrays 1, 2, 3 and 4, 5, 6, they are joined. Now stacking. Stacking is same as concatenation. The only difference is that stacking is done along a new axis. So if we just take the arrays from here, and we will write here arr dot np dot stack and then arr1, comma arr2, then axis is 1. Then we will print arr. So you can see 1, 2, 3, and 4, 5, 6, both the arrays are joined here, just the axis is different. If we need to stack along rows, we can just first copy this. Stacking along rows. So here we need to use np.hstack. Hstack is for rows and do not have to define the axis and simply run the program. So you can see it has been stacked or joined through rows. If we wanted two columns, you can just use vstack instead of hstack. And for stacking along height or depth, we can just use dstack here. Now the next thing is to splitting NumPy arrays. If we take splitting, if we take array as 1, 2, 3, 5, 6, and new array as np dot array, then split arr, 3. Then we will print this new array. So you can see that has been split into 3 new arrays. This, and this. Now if we want to split the 2D array into 3 2D arrays along columns, then we need to mention the axis. So 2D into 3 2D arrays along columns. So arr equals to np dot array 1, 2, 3, and then 4, 5, 6, then 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16, 17, 18. Then is new array is equal to 1p dot array, and we need to split it along columns. So arr, 3, and we can mention the axis. Now let's print this. So you can see that this is printed into 3 2D matrices. So you can see this is 1, then this one is 2, and this one is 3. And they're joined along column. Now alternate solution to do this is using hsplit. You can try that yourself. So the next thing, to search an array, we can use the where method. Where. So if we want to find the index where the value is 4, first let us create the array again, like 1, 2, 3, 4, 5, and then again we can get 4, 4. then x is equal to np dot where arr is equal to 4. Then we will print x. To save this and run. So you can see 3, 5 and 6 on the answers means 0, 1, 2, 3. So third index, fourth and fifth. Oh, sorry. Third index, fifth and sixth. If you want to find the indexes where the values are odd, then it's also easy. First, we can take any array. We could write more number 6, 7, 8, and then x is equal to np dot where, and then we will put the condition that array divisible by 2 is equal to 1. That is the remainder when the element will be divided by 2 should be equal to 1. And then print x. So you can see this is printed 0 to 4, 6. So 0, 2, 4 and 6. So it has printed the indexes where the elements are odd. So the next thing is search sorted. Search sorted returns the index where the specified value would be inserted to maintain the search order. If we just let me just show you by an example. X is equals to np dot search sorted arr comma 7. If I print this x, then you can see 1 is printed because we had written here that 7 or the index of 7 has to be printed. So 7 it is at the first index, and so 1 is printed there. If we want to search from the right side, by default the leftmost index is returned. But we can give side equals to right to return the rightmost index instead. If we make an array, can take the same one. And if we want to find the index where the value 7 should be inserted, starting from the right, then we can write x equals to np dot search sorted and then arr comma 7, like we have written before also. Just we'll change the side, that is right. Alright, we have not printed, so we need to print x. So 2 is the answer and 0, 1, 2. So yes, 2 is the answer. Now if we want to search for more than one value, like farr is equal to np dot array 1, 3, 5, 7, and x is equal to np dot search sorted, then arr comma we can just write 2, 4, 6. Now if we print x, so you can see 1, 2 and 3 is printed. It means that if we insert these 2, 4, 6 elements in this list, it will still be sorted. Like 2 can come here, then 4 and then 6. So at the first index and then at the third index and then at the fifth index. So it is showing 1, 2, 3 according to the current situation that we can put 2 at the first index here, and then before 5, that is at the second index, we can put 4, and then at the third index we can put 6. Similarly, it has shown here that from the right, if we put 7 here, we will still get a sorted array. So we can put, so from right, we can put at the second index. So the answer was 2. Here also answer was 1 because we could have put 7 here and still it would be sorted. Okay, so let's comment this and see the next one, which is sorting arrays. If I want to sort an array, this is already sorted. We just jumble it up like this and we write print np dot sort and then array. So you can see our array is sorted 0, 1, 2, 3. It is sorted in ascending order. Now next thing is to filter. Now if the value at an index is 2, that element is contained in the filtered array. And if it is false, then it will not be there. For example, if ARR is equal to np dot array, then 41, 42, 43, 44, and x is equal to true, false, true, false, and new array is equal to array, and then x, and then we'll print new array. So if we run this, we got 41 and 43 are the answers, and I already told you true is 41, 43, so it will be contained in the new array, else it won't be there in the new array. So the next thing is to create a filter array that will return only values higher than 42. Filter and filter which is higher than 42. So for this, we just take the same array and then we can create an empty array, then for element in ARR, if element is greater than 42, filter ARR dot append true, else filter ARR dot append false. Then URR is equal to ARR filter ARR, and then we will print this. And also we will print new ARR. So you can see 43 and 44, they are greater than 42, and so only they are printed. So what have we done is we have written the for loop, and then inside it, if element is greater than 42, then true. If it is not greater than 42, then it will give false, irrespective of the initial values if we have given any. So this was all for this video. Thanks for watching. Make sure to like, share, and subscribe for more coding content. Happy coding!